All right, here we go. Lesson 22. Don't we have your correcting pen? Those of you who didn't finish, you can finish it along with us while we're working. Arabella and Barrett and I, you just needed one more minute, so I know you'll be able to finish it up. All right, are we ready? Okay. Help me with the first part. 4 times 9 is?
36.
4 times 2 is?
8.
5 times 5 is?
25.
9 times 5 is?
45.
6 times 9 is?
54.
7 times 1 is?
7.
36 divided by 4 is?
9.
72 divided by 9 is?
8.
36 divided by 6 is?
6.
8 plus 2 is?
10.
3 plus 9 is?
12.
6 plus 7 is?
13.
9 take away 7 is?
2.
14 take away 8 is?
6.
13 take away 4 is?
9.
Awesome. Give yourself a big star if you got all those right. Okay, I'm going to write these numbers up and down so I can add them. And then I always start in the ones place. So I've got 2, 7, 8, 9, 10, 11, 8, 9, 10, 11, 12, 13, 14, and 2, and 8, and 12. Did you get 1,282,412?
Yes. Yeah.
Give yourself a star. 1 million.
I didn't really notice that.
So remember we put a comma after every 3 place values, right? To give we have our hundreds period or family, our thousands family, and our millions. Yep, Naya's pointing to her place value chart. Did you notice there's a place value chart above your name?
No.
On your name tag?
Yeah.
Look at your name tag. All right, we're gonna do subtraction. Zala, where's your drops, babe? Look until you find them. 7 take away 6 is 1. Now I have to do some regrouping. 8, 9, 10 plus 6 marks, so that 4 will be 6. Then I've got 2, regrouping again. 7 and 2. Did you get 27,261?
Yes.
Okay, I'm all set up here to do shortcut method. I'm going to ignore the decimal. So I'm going to do 2 times 3 is 6. 2 times 5 is 10 after regroup. 2 times 1 is 2 plus 1 makes 3. Then I'm going to count up how many decimal places I have overall. None in the 2. And then 1, 2 up here. So then I'm going to put 1, 2 down here. So my answer is 3 and 600. Fabulous. Okay, now if I look at my math facts chart, I know that 86 is not on there as a multiple of 3. So I'm going to have to do some long division. And I bring down my 2. I'm just using digit by digit. 3 times 8 is 24. Which leaves me a remainder of 2. Did anyone get 28 remainder 2?
Yeah.
Beautiful. All right, fractions. Let's count how many parts. 1, 2, 3, 4, 5, 6, 7, 8, 9 jumps. 1, 2, 3, 4, 5, 6 ninths. Did anybody get 6 ninths?
Yep.
And if I divide by 3, I can get 2 thirds. But you can multiply and divide by any number as long as the top and the bottom are the same. Yes, Lawson?
On the $1.53 times 2, when I would like go through it like before we go, and like I said it was wrong because that was my original answer, but when like I go before it right before we correct, and like I like read the question again and stuff.
Double check everything.
And I changed my answer before you corrected that one.
Beautiful. So the reason that we're using a correcting pen is really for you to see what you needed to fix, and then you can feel free to fix it. I'm not scoring these or anything. I just want you to learn from any mistakes that you discover. That makes sense? Sammy?
I was just wondering if you could times them.
Yep. Yeah. You can multiply as long as whatever you do to the top, you have to do to the bottom. So if you ended up with 12 18ths, that would work. Yep, that is an equivalent fraction.
What about 6/9?
6/9 is the fraction.
Then you can do the same side because it could be equal because 9 times 6 equals 54, 9 times 6 equals 54.
I don't understand what you're saying.
You can do the same thing on both sides.
You could get to 54, but you wouldn't be doing the same thing. You would do 6 times 9 and 9 times 6. So you would be multiplying the numerator and the denominator by different numbers. So you can't do that for an equivalent fraction.
Well, I think what he's saying.
Nope, we got it, right? What he's saying is, if you have a 6 and a 9, you can get to 54 with each of them, right? But you have to do 6 times 9 and 9 times
Yes.
6. But you can't, this is not equal to 1 whole.
I didn't do that.
Yeah, so this is not equivalent. Whatever you do to the top, you have to do to the bottom. Like Sammy was saying, what if I multiply by 2? You can, but then you have to multiply by 2 halves because 2 halves is the same as 1 whole, right? Mm-hmm. So as long as it's the same on the top and the bottom, it works.
I did the same thing for the first one, but I switched the numbers around.
So you'd have to do either 9/9 or 6/6. That make sense? Yep, cool. Yeah, that's the magic is it has to be, for it to be equivalent, and we'll learn more about this in our next unit, we have to be multiplying by the same number on the top and the bottom because that's equal to 1 whole. Barrett, question about that?
At first, it was kind of a process, but right when you were on, the 3 divided by 86, I checked that one, because I knew there was something fishy with that, and I was like, and my first answer was, 6/8. And I was
Ew.
like, is this good?
So were you able to
And
figure
then I
out,
checked, and I was like, why in the world did I get that?
did you find your mistake?
Yeah.
Okay, cool. We're gonna move on, honey bun, so we can finish.
And then you got on that one, and I was like,
Oh gosh. Okay. So many 56s. So we talked about this yesterday. 1 inch is what part of a foot? So we said if we have 1 foot, we need 12 inches to make a whole, right? A whole foot. And so if we had 1 inch, we would have 1/12. And our magic word for fraction is part. A fraction is, if someone says, yeah, you can have part of my cookie, you know you're not getting the whole thing, right? Okay, divide to simplify. So the 18, remember we can read this, 18 divided by 6. So the 18 falls off and goes inside the bracket. And the 6 goes on the outside. That's why it comes backwards, right? We say 18 divided by 6. And the answer is 3. 3 wholes. Okay, we're going to compare these fractions. We have the same denominator, which means the sizes are going to be the same, right? The size of the pieces. So do you want 4 of them or do you want 6 of them? We always want 6. We want more cookie. All right, so this is an area problem, disguised, because it does not use the word area, right? But last week we did a problem, was it also with rugs?
no.
An area. You guys remember it had like 2 little ones and you had to figure out the area? Okay, so this is telling us this is pools. Pool A is 15 feet long by 9 feet wide. So if we had it, we would have something like this, 15 times 9. And pool B, this is A, and pool B is 14 feet long and 10 feet wide. This is B. Which pool is bigger? So it didn't say this word, but we're really trying to find the area. And when we find the area, anyone remember what operation we do? Brandy?
What operation do we?
Add, subtract, multiply, or divide. Lucas.
Well, these have more than that. Like they have like more than one.
Are we going to add, subtract, or multiply or divide to find the area of a rectangle?
Oh, times.
Yep, multiply. So we are going to do two problems, right? 9 times 15 and 10 times 14. 10 times 14, that's easy. I don't even have to multiply. What do I get? 140. Okay, and so then I'm going to do 15 times 9. I get 45. 9 times 1 plus 4 is 13. So I got 135. Did you get that?
Yes.
So which one's bigger?
B.
B is bigger. How much bigger?
5 square feet.
Yep,
5 square feet.
because 140 take away 135 gives you 5 and square feet. Good remembering on those units.
Oh, I
Yes, Lawson?
wrote 5 feet bigger.
So it's 5 square feet. Those are the units because this is feet and this is feet. And when you multiply feet by feet, you get feet squared. Which really just means it's not just 1 foot this way. It's also 1 foot this way and a whole square. So 1 foot, 1 foot, 1 foot, 1 foot.
The answer, right?
Just change it. Okay, a fraction's blank tells how many parts it was cut into. What'd you write?
Denominator.
Yep, we talked about that, didn't we?
Yeah.
A paper clip is about 1 inch long. We write noon at midnight without the letters.
AM or PM.
Yeah, these are our time.
I did the opposite.
Fine. That's because that's how it's listed over here. It's totally fine. Multiples of 5. Ooh, this is from our tricks. Multiples of 5 always end in 0 or 5. Okay, so now we're doing down to measurements going backwards from millimeter to centimeters, which means we're not multiplying, but we're dividing by 10. So we're going to move the decimal this way. So we can have a pretend decimal here. It's really there, we just don't write it. And so we're going to divide by 10, which means we're just going to move the decimal over one place in each one of these millimeter measurements. So that makes 1 3/10 centimeters, 5 9/10 centimeters, and 10 9/10 centimeters. How'd you do on that one, Sammy?
Horrible.
Oh no.
Easy cheesy lemon tea.
Did you work too hard?
No,
Oh.
I did what I was taught, but I still failed.
Huh. You must have a terrible teacher.
Yeah.
85,250. Forgot to say write it, didn't it? In this number, the 1 means 100,000, which is the same as 1 times 100,000. And if
10 times 10,000. Does that work?
10 times what?
10,000.
Yep, that does work. Expanded notation. So we're going to draw out each one of these digits and write its place value. So the first 6 is worth what?
60,000.
Yep. And then we've got 6,000. And yeah, I'm just going to leave that blank. And 40 and 4.
4. I just wrote 12 there.
10 more than this number. So I'm looking in the tens place and I've got a 3. So if I'm going to give one more 10, I'm just going to change that to a 4. So I've got 714,240.
Yes.
Draw a long horizontal line and print the word horizontal. So Lucas asked me about this. Remember, horizontal goes this way. If you looked out, you would see the horizon. Not here, it's blocked by trees. Okay, and also, what is that word on the map that talks about the lines? Latitude. We call this one latitude, flatitude,
And then this is
longitude. So we got a horizontal line, horizontal.
That was kind of fun to do.
That was easy.
Okay, here we're gonna do find the sum. When we see this word sum, what operation do we do? Add, subtract, multiply, or divide? Using decimals. So shaded, I've got 2/10. unshaded, I know I've got 8. 1, 2, 3, 4, 5, 6, 7, 8. We'll just count them to make sure they're not being tricky. And 8/10 plus 2/10 equals 1 whole. So you can write it like this, 1. You can write it like this, 1. Either way, it's still 1. A mango tree was 8 feet tall when we planted it. Now it is 4 times as tall. Write an equation with h standing for its height now. So it was 8 feet when we planted it.
8 times 4.
Now it is 4 times as tall, equaling h, its current height. Yes, Lawson?
Okay, so decimal problem.
Number 9.
Mason scammed me.
Mason.
He told me.
Tell me of the trickery. What did Mason say?
He said it was 0 tenths.
No,
I wrote 1 to start, and then he said
No,
no,
you-
it's 0 tenths.
No, you did that to me. We are.
Lee, tell us the truth. Who did what?
Okay, I asked Lawson what the, because I didn't know, so I asked Lawson, and he told me it was 0
Yeah,
tenths.
because Mason
So he
told me
scammed
it was.
me.
because
Well,
Mason
it's
told me
true. There's 0/10, but there's also 1 whole. Wah, wah.